Okay, so the ball doesn't always stop at the top of the motion, and somehow in grade 9 or grade 10 or maybe even grade 11, people get this weird notion that when things get up to the top of their motion, their speed is always 0. That's not really necessarily true. It's only maybe true if you launch things directly vertically, but for some people, for some reason, people get hung up on this. So this kind of looks like some line dancer or something, whatever. Anyway, so this is a person kicking a ball. If a person kicks a ball, though, and it starts off at some initial height, goes falls down at the bottom. Well, that was supposed to be a parabola. Up at the top, there seem to be a lot of people that still get hung up on this thing having a velocity of 0 at the top. You guys know by now, with all these angled projectiles, that at this point there's a horizontal component of velocity and a vertical component of velocity. And generally, you can calculate that if you know the trajectory angle, initial trajectory angle, and the initial velocity. You can figure out a v1x. If you have a v1x, what can you tell me about the x component of velocity throughout this thing? Yeah, so you really should have a vx at this position and a vx at this position. The best you can say is that that's where the velocity is minimized. The magnitude of the velocity is minimized. So if I tried to do an energy analysis of this, I could choose this as position A, I could choose this as position B, and I could choose this as position C, and I might say E total at position A is equal to EKA plus EGA. Fine. At this position, I might say E total B is equal to EKB plus EGB, and so on for part C. Now, if this is a 100% efficient system, all I can really say is that each of these E totals are going to be equal to each other, much like if we were analyzing that 100% efficient roller coaster we talked about previously. But what we can't say is that EK is equal to 0 at this point. Any EK that we calculate at this point is going to be based on the Vx, which is going to be constant throughout. It's not equal to 0. And I see so many people saying that the kinetic energy at the vertex of this motion is equal to 0. It's not. I mean, that's just silly talk. That's like ignoring everything we knew from kinematics. Please don't do that, okay? That's the only point that I want to make here, is that you can't zero out this kinetic energy just because it happens to be at the top. It's still a part of the kinetic energy. Clear with that? Good. Yeah?
I'm just going to say Vy is 0.
You could say that Vy is 0, but still we don't really deal with that direction when we're dealing with energies. We're just talking about the magnitude. But you can't ignore that there's x and y components, which is where that speed is coming from. So you do have to recall back to your kinematics days to solve these guys sometimes.